Question 5. Question 5, it's rate of reactions. But lana, we are doing an experiment. Basiphe a question based on an experiment. Right, in the description below, uzothola ama links for amanye questions akhona kule question paper yaka November 2016 ye-chemistry. Right, lana bathi a group of learners uses the reaction between powdered zinc and excess dilute hydrochloric acid to investigate one of the factors that affect the rate of a chemical reaction. The balanced equation for the reaction is given below. Lana, we need to be careful, but they investigate one of the factors that affect the rate of a chemical reaction. So a rate of reaction affect factors ayingaki. Let's count as bali: concentration, temperature, pressure, as well as catalyst. What else? Oh, state of division. That's the fifth one. Okay. Now, what did they conduct? 2 experiments. The reaction conditions used are summarized in the table below. So we have experiment 1, experiment 2. Temperature is constant for both experiments. Volume of hydrochloric acid is kept the same. Concentration of hydrochloric acid change. So since there's a change in concentration of hydrochloric acid, it means the factors is we are investigating one of the factors that affect rate of reaction. Out of the 5 there's only one as the investigator. Since concentration change table, it means we are investigating any concentration, and then they don't state the mass of zinc used, and then the zinc esisebenzisayo is also powdered, but the state of division for zinc abasitsheli anything except for the fact that powdered. So the only thing that changes is what? Is concentration. So we are investigating in rate of reaction. How is it affected by a change in concentration? The results obtained are shown in the graph, not drawn to scale, the one below. The graph of so this is the graph of volume of hydrogen produced versus time. So the gas of the volume of a gas hydrogen that is produced is measured what? Against time. So every time hydrogen gas is produced, we are recording volume yakhona. So why is measure hydrogen gas? Because it's one of the products of the reaction as study shayo. Zinc and hydrochloric acid is zinc chloride plus a hydrogen gas. Now 5.1, but define reaction rate. Reaction rate, question 5.1, define a reaction rate. Well, a reaction rate can be defined in so many ways. Also, a reaction rate can be defined in terms of our products, can be defined in terms of our reactors. So I think it define in terms of our products. Where do we define in terms of our reactants? It's still fine. The change in concentration of product per unit time, or the rate of change in concentration of our products, or rate of change of our reactants. So that's 5.1 for us. 5.2, write an investigative question for this investigative question. So 5.2, we need to say ukuthi si-investigator ini kule experiment le, right? We are conducting an experiment. What are we trying to understand from the experiment? What are we actually studying? Sifuna okwazini through the experiment. Like sifuna okwazi ini. We want to know what is the relationship. What is the relationship between what's this? Between concentration, as I've stated before, with the actually we are investigating one of the factors that affects the rate of change. So sifuna ukwazi the relationship between concentration and reaction rate. That's what we are studying la. What is the relationship between concentration and reaction rate, right? Sifuna ukwazi lokho. So 5.3 siya ku 5.3 ke manje. But which curve P or Q represents the results of experiment 1? Explain the answer. Explain the answer. So mawuthatha ukubheka between the two curves, ne? Curve Q has a steeper gradient, ne? Both gradients are increasing, but the steeper the gradient, the greater the reaction rate. So P siyabona ukuthi une greater reaction rate than Q. So Q has a less reaction rate, P has a greater reaction rate. So now, but which curve P or Q represents the experiment 1? So experiment 1, constant concentration. Experiment 2, constant concentration. Siyabona ukuthi there's a change in concentration. The greater the concentration, the greater the what? The reaction rate. So siyabona ukuthi experiment 1 has less concentration. Meanwhile, everything else is constant. So the concentration is less to experiment 1 than to experiment 2. So therefore, experiment 2 is over a greater reaction rate. So P has a bigger reaction rate than experiment 1. So experiment 1 is actually curve Q. Ngoba une less reaction rate because of the lesser concentration. So therefore Q is our answer. Q represents experiment 1. Represents experiment 1. But explain the answer ne? But sibuye si explain lo kanje answer yethu la. Okay, singathi curve Q has a smaller gradient compared to P. Therefore the reaction rate for experiment 1 the reaction rate for experiment 1 will be less. And then this is teeny. The reaction rate for experiment 1 will be less because the hydrochloric acid has low or has the lowest concentration Therefore, the reaction rate will be less because hydrochloric acid has the lowest concentration and will take longer to reach completion. So try to be as detailed as you possibly can when when you are given the opportunity to explain anything, ne? To explain anything. So now kule question elandelayo le seso-calculator la. And this question 5.4, the average rate of production of hydrogen gas is represented by graph P, or the average rate of production of hydrogen gas as represented by graph P was, so graph P with the highest reaction rate yakhe bathi it was what, 15 cubic centimeters per second. Calculate the mass of zinc used. Take the molar gas volume at 25 degrees as this. So what is the reaction rate at this temperature, 25, the molar gas volume at 25 degrees is given as this. Okay, Lana, we want to calculate the mass of zinc. Meanwhile, basiphe ini the rate of production for the hydrogen gas. The rate of production for the hydrogen gas. So Lana, in order to find mass ka zinc, I need the number of moles for hydrogen gas. But even before we can find the mass ka zinc, we also need the number of moles for zinc. So in order to find the number of moles for zinc used, I need the number of moles for hydrogen gas that are produced. So since basiphe reaction rate nelo kanye molar volume, so it means I can calculate the number of moles, but first I need to find the volume that is produced for a hydrogen gas. I hope uyayilandela logic yami la. But anyway, since basiphe rate, rate as equal to, rate is calculated as the change of change in concentration, change in volume over change in time. National my units ask guidelines, volume per unit time. So rate is change in volume over time. Sometimes the rates is calculated as change in mass over time. Since basiphe one as change in time, change in volume per unit time. So therefore it means the formula komele ngisebenzise nayi ke. All right again. Now the rate of change la, the rate of change as ngayicalculate ngani, singayicalculate nge-gradient between 0 and 30 seconds. Why between 0 and 30 seconds? Because at 30 seconds that's where reaction yethu reach equilibrium. So we're going to find the average gradient between 0 and 30 seconds. So therefore, in other words, in a rate as well as time, I can find the volume. The volume exoitola la izonceda ukuthi calculate the number of moles for hydrogen gas produced. So lana we have 15 equal to its volume final minus volume initial over time final minus time initial. So it's 15 la equal to final volume sifuna yona minus what is initial volume, it's 0, because at time 0, at T0 volume is also equal to 0. Remember, hydrogen gas is a product la. T final is 30 seconds minus T initial, it's T0. So therefore, it's 15 equal to TVF over 30. So I cross multiply, I end up something like 30 times 15 equal to V final. So V final is equal to 30 times 15 ngithola 450 cubic centimeters. Remember, this is second. The 15 is 15 cubic centimeters. So the units for volume is over cubic centimeters again. Now, the number of moles for hydrogen gas is equal to volume over molar volume. The number of moles can also be calculated by using volume. Also, we have two formulas for finding the number of moles. The number of moles can be calculated as V over Vm or as N over Na, the number of particles over Avogadro's number, or mass over molar mass. Since we molar volume, so it means we need to use this formula. And this formula, we can only use it if we have the volume formed, right? So we have the volume formed, start we calculate, which is 450 divided by molar volume, it's 24,000. So in most cases, units way to try to convert it to cubic decimeters. Now, since molar volume is cubic centimeter, so it means the volume is cubic centimeter. So now let's calculate 45 divided by 24,000. The number of moles is equal to 0.01875 moles of hydrogen gas. So therefore, this is not the final answer. So that's why I round off to 2 decimal places or 3 decimal places. Ngibhale yonke le answer so that the final answer is a bit more accurate. Now, sisiyaqhubeka ke manje. I have the number of moles for hydrogen gas. Thina sifuna the mass for zinc. Now chemical equation yethu. The balanced chemical equation, there's a 1:1 ratio between hydrogen gas and zinc. So therefore, 1 mole of zinc produces 1 mole of hydrogen gas. So therefore, there's 1:1. So therefore, it means if I have 0.01875 moles of hydrogen, it also means I also need 0.01875 mole of zinc to produce this much. So therefore, the number of moles for zinc is equal to 0.01875 mole. So therefore, now I have the number of moles for zinc and also the number of moles. Since ngifuna the mass for zinc used in a number of moles, I can find molar mass ye zinc. So it means that the number of moles is its mass over molar mass. Since ngifuna mass, I can use this formula to find mass. Ngifuna mass, I can use this formula, mass over molar mass equal to zinc. So therefore the number of moles is equal to 0,01875 equal to, we want the mass. What's the molar mass for zinc? Molar mass for zinc, zinc. Uphi zinc. Now it's what? It's 65. So the molar mass is 65. Cross multiply, mass is equal to 0,01875 times 65. Mass is equal to 0,01875 times 65 is equal to, now this is our final answer. As you express it in 3 decimal places, is 1,219 gram of zinc was used for this experiment. So iphelela la equation ka 5.4. now siyaqhubeka ke manje, now ku 5.5 but in a third experiment, experiment 3, 200 cubic centimeters of 0,25 mole per cubic decimeters of dilute hydrochloric acid solution at a higher temperature this time react with the same amount of zinc powder as in experiment 1 and 2. Now the question is, before spendula my question, I think pose a question. Yini into eyichangeile la? The volume hasn't changed, the concentration hasn't changed when uma si compare no experiment 1, but it different for experiment 2. Ngoba experiment 2 sino 0,4. The only thing a change la kahle it's what? It's the temperature for all the experiments. The only thing a change in Luganje is temperature. You must compare all the experiments. So the temperature is actually from the experiment is actually from 25 degrees Celsius to a 35 degree Celsius. Now what take it 5.5.1, how will the heat, it's not heat and like now. How will the rate of reaction of experiment 2 compare with that of experiment 3? Choose from more than, less than, or equal to. Alright, again. The only difference between experiment 3 and experiment 2. Experiment 2 and experiment 3. The only difference is concentration. Experiment 2 has a concentration of 0,4 and then experiment 3 has a concentration of 0,25. Now according to ecology theory, we know that the higher the concentration, the greater the rate of reaction. So since we experiment 3 on a lower reaction rate than experiment 2, ne? So the rate of reaction azolingana, ne? Because the lower concentration is being compensated by the higher temperature. Back 5.5.1 experiment 3. Experiment 3, the concentration ga experiment 3 is equal to 0,25, but the temperature is equal to 35 degrees Celsius. Experiment 2, as us compare experiment 2, how will the rate of reaction of experiment 2 compare with that of experiment 3? Choose from more than, less than, or equal to. The concentration ga experiment number 2 The concentration of experiment number 2 is 0,4 as shown on this table. Experiment 2 concentration yakhona 9. And then the temperature is equal to 25 degrees Celsius. How does the reaction rate compare to the one experiment number 3? Now, since we experiment 2 on a higher concentration than experiment 3, and then on another aspect on a temperature, lona une higher concentration but low temperature, lona une low concentration but high temperature. So we are one mina since ngine high concentration but mina ngine low concentration, so since there's a difference in concentrations and a difference in temperature, because ngine low concentration, a high temperature ya compensate lana ngine high concentration but a low temperature. So therefore lana actually there's no change kahle. Ama reaction rate azoba equal to ngoba lona less nga something but to compensate by something else, ni higher nga something but ni shorter nga something. So there's a balance kahle la. I'm low in concentration but high in temperature, high in concentration but low in temperature. So therefore the reaction rates are over equal ngoba we experiment 3 we have a compensation of a higher temperature. 5.5.2. How will the activation energy of the reaction in experiment 1 compare with that of the reaction in experiment 3? Choose from more than, less than, or equal to. Activation energy. Check out. Activation energy is only being affected by one thing and one thing only, a catalyst. So since in experiment 3 no catalyst was used, as well as experiment 1 there was no catalyst used, so therefore the rates of reaction as over not the rate of reaction but the activation energy will be equal to my activation energies wakhona, because the only thing a change activation energy is a catalyst. Now for the last question, the rate of reaction in experiment 3 is higher than that of experiment 1. Fully explain this answer by referring to the collision theory. So the collision theory in order for a reaction rate increase, so we need what? More effective collisions, and particles they also need a what? A high kinetic energy. So therefore we experiment 3, as mentioned, we have a higher temperature than we experiment 1. Experiment 1 is 25 degrees, experiment 3 there's 35 degrees, and our concentrations are fine. We have also the only difference in this case in our temperature. So therefore lana answer it is what the rate of reaction. Okay, fully explain this answer. Last year I explained why the reaction rate would be higher than we experiment 1. It's because at high temperature the average kinetic energy of molecules is higher and okay, because at high temperature the average kinetic energy of molecules is higher and the more particles, the more particles gain enough kinetic energy, and the more particles gain enough kinetic energy, more effective collisions per unit time they occur, full stop, something like this, ne? I'm just trying to demonstrate with in your statement kwamele include some keywords: high temperature, average kinetic energy, and then effective collisions per unit time. Lawa ama keywords azokupha ama marks lawo, ne? Or even if unga-explainer, instead of using lama keywords lawo, it's best ukuthi in your statement at least mention something along these lines lawo, but the more usebenzisa lama keywords, the higher the chances of getting ama full marks. So thanks for watching. Ungakhohlwa ama keywords wakho. Thanks for watching. In the description below uzothola ama links for amanye ama questions, and then I hope le video ikuncedile kakhulu. Ungakhohlwa ukulike le video nangabe uyi-enjoyile. Ungakhohlwa nokusubscribe nangabe awusubscribanga. Ngizokubona kule video elandelayo, and thanks for watching. Peace.